All right, so we're going to do a bit of application to the piecewise linear function. So the number of U.S. travelers to Canada in the millions for selected years is shown in the graph. So here we have the years in 1990, 95, 2000, 2005, 2010. And this is how many travelers there have been in the millions. So in 1990, just over 12 million. 1995, it increased. 2000 kind of peaked. And then as time went on from there, it's gone down. Okay? So, and this is real life data. Ooh. Now, right here, now, we're going to let x kind of like be 0, which is the 1990. So we're going to let 1990 be like 0. We're going to let the year 2000 be 10. The year 2000, and I'm sorry, the year 2000, the year 2010 then to be 20 years. So basically, these are all going to go in increments of 5. So this is like 0, 5, 10, 15, 20. Okay. So we want to use the points on the graph to write the equations for the line segments in the intervals from 0 to 10, right here. Bloop, bloop. This is from 0 to 10. And the intervals from 10 to 18. And notice that and this guy right here that we use parentheses. So the parenthesis means the number is not included. The brackets means the numbers are included. And that information is going to be useful to us, and I'll show you how that works. Okay, so we want to use the points on the graph to write equations for the line segments. So we want to write what is the equation of this line segment and what's the equation of this line segment. And then define f of x for a piecewise function. What would the piecewise function look like then? So we have two things to do. First, find the equation of each of these lines and then write it as a piecewise function. Okay, so a lot of this is just review of using the slope formula and finding the equation of the line there. Okay, so there's, first of all, we have the slope formula. And the slope formula is y2 minus y1 all over x2 minus x1. Okay, so if I want to find the slope of this line right here, I'm going to go ahead and I'll make this my x, maybe I'll make that my x2 actually. It doesn't matter which one you make it, but I'll make this my x2, y2, this would be my x1, y1. So now I'm just going to plug straight into here. Y2 minus Y1. So 15.188 minus 12.252. So let's definitely busting out the calculator. So 15.188 minus 12.252. Okay, so this represents Y2, Y2, Y1, Y1, all over 10 minus 0. Okay, so we'll use the calculator to calculate these guys right here, and just doing this right now. So in the numerator, excuse me, we'll get 2.936, and we'll get that all over 10. Okay, and you could also reduce that right there, just being 0.2936. Okay, all right, so again, this right here stands for our slope, and I'm going to label that as M. Okay, so we found our slope of this line right here. Now check this out. The easiest way to write an equation of a line, at least in my opinion, I mean there is point slope formula, but I like to just use the slope intercept form. Y equals mx plus b. Okay, of the slope and the y-intercept, we already have the m right now, meaning y equals 0.2936x plus b, right? So we know what the m is. All we have to find now is what is the b. So the way that you find b, check this out now, is we choose one of these 2 points. Okay, and I'm going to choose this point right here. Okay, it doesn't matter what point you choose, just choose one of them. Okay, and what you do is you do this right here. This 0 represents the x number. This 12.252 represents the y number, meaning plug in 0 in for x, plug in 0 for x, and plug in the 12.252, and plug that into y. If I plug in 0 for x and then 12.252. And for y, I can solve for b. Oh. And obviously, if this is 0, then b must be 12.252. And that one just happened to come out nicely because that one is 0. Okay, so now that we know that the b is just the 12.252, we can now write the equation of this line right here. The equation of this line is y equals mx plus b. The m is 0.2936x, right? Plus b, plus 12.252. Okay, so all that work right there, we just found the equation of this line. So now what about this line? Well, we got to do the same thing here as we did for the previous problem here. We have to do the slope formula and then find the b. So let's go ahead and do this again. y2 minus y1 all over x2 minus x1. Okay. And I'll still make this my x2, y2, and this will be my x1, y1. Okay. You know what? If you want to, you can switch these two right here. You can make this your x1, y1 and your x2, y2. You get the same answer. Cool beans, all right? So let's go and plug it in. 15.188 minus 12.495. And that's all over 10 minus 18. Okay, look right here. I did y2 minus y1. That's why I got this minus that. And then I did the 10 minus 18 right there. Okay? So 15.188 minus 12.495. Cool. So we get a decimal of 2.693. And notice this here, 10 minus 18 is a negative 8. So we're going to have a negative slope right here. And that kind of makes sense because look, if the line's going down, we should have a negative slope. And that written as a decimal is negative 0.336625. Okay, so that's the slope. But we need to find the y-intercept, right? We need to find what is our b. So as of this, mx plus b, I know that this right here is my m. So I'm going to plug in my m right here. So y equals negative 0.336625x plus b. If I want to solve for b, I need to choose one of my 2 points. It doesn't matter which of the two that I choose. I just need to choose one of these. Okay, and I'll choose the one right here, the 18 and 12.495. So I'm going to plug in 18 for x, and y value will be my 12.495. A lot of work here for this little guy. Okay, so let's do that. So I'm going to replace the y with 12.495. Leave that as it is. My x value is 18. So times 18 and then plus b. All right. So now let's go ahead and just simplify this guy. Now let's go ahead and multiply this together. So multiply that guy by 18 and we'll get negative 6.05925 plus b. And in order to solve for b now, I need to add the 6.05925 to both sides. Those are gone. And let's see what we get here. So 6.05925. I'm going to add that to 12.495. And we'll get 18.55425. Okay, so we have our b. We have our m, which is enough now to do our equation. So that equation is y equals negative 0.336625x and then plus b plus 18.55425. 425. Okay, so we did the first part of the problem here, which stated use the points on the graph to write the equations for the line segments within this interval from 0 to 10 and then from 10 to 18. Now, then define our function f of x as a piecewise function. So we're going to kind of write it as we did like for this kind of problem. See how we write it like this, where we have like two functions, okay, or something like this. We're going to do the exact same thing now, all right? So we have the equations of both of our lines. We have, let's see, where's the first one at? There it is. So we have this guy right here. So this is our first one. We got this dude. And then we have the second one, which is right here. That was really off. Okay, so here we go. How do we write this as a piecewise function? So check this out here. Check this awesome nerdiness out. So we're going to do f of x equals. Okay, so notice that we're only going to graph this line from 0 to 10. Okay? And that's what we're going to do here. Let's write down the equation of this line, which is right here. So graph points 2936x plus 12.252, but only in the interval, watch this now, from 0 to 10. Okay? And you can represent it just as, you know, I mean, that kind of gave it to us from 0 to 10. Maybe like another way that you could have represented this right here is you could have said where x is in between 0 and 10. Okay, you could have replaced this as doing this kind of notation as well. Okay, but then we want to graph this guy from 10 to 18. Okay, and we're given the interval right here. But notice that 10 is not included, so we're going to have to use the brackets right there. I'm sorry, the parentheses. So we're going to graph negative 0.336625 x plus 18.55425, but only from 10 to 18. Okay, and so this would be a representation of the piecewise function for our data that was given to us up here.